Hi there, friends and neighbors. I'm going to show you a complete example of a MultiwayANOVA results section. I'm going to kind of skim through this because it's a little more detail, a little more advanced, and is really appropriate for such a introductory class. But I'm going to just kind of do a quick and dirty example. Now, it really should have more detail. You really should have more than a week to learn how to do ANOVA. Anyway, descriptive stats are something you'll need, and then you need a graph, and you need inferential stats. As always, that includes HO, H1 alpha, assumption check, which we will keep light, your test statistic, degrees of freedom p-value, that's an ANOVA summary table, decision, and interpretation. Okay. And what I'm going to play with, I've already got the data set loaded. It is grades as predicted from whether or not students revised Test 5 and Test 7. I'm going to dive right in. So statistical analysis, continuous variables, one-way ANOVA. I'm going to choose estimated grade as the outcome, and the binary variable of did you revise Test 5 and did you revise Test 7. And I need some way of following up. I'm going to do a Tukey follow-up comparison. That way, if it's significant, I'll find out why by seeing which groups are different from which others. Click OK. And it gives you a nice graph. And uh-oh, that's not what I wanted. Oh, I ran it wrong. Statistical analysis, continuous variables, MultiwayANOVA. All right, that's what I did wrong. MultiwayANOVA. That's what we're doing here. Is a MultiwayANOVA. Yes. So revise Test 5, revise Test 7. Ah, yes, yes. And then click OK. Now what this is going to give me is 3 hypothesis tests. And it works like this. They're always the same. HO, revising test. Well, there's no main effect for test 5. H1, main effect. That is, there's no mean differences whether you revise test 5 or not. Secondly, we're testing simultaneously the same thing for test 7. And then we're testing for what's interesting is the interaction effect. Test 5 and test 7. An interaction effect means something special happens if you look at a combination of the two factors. And it's not a main effect. So no interaction effect, or yes, there is an interaction effect. Interaction effect means something special happens if I, let's say, revise both tests, or some one combination of those 4 possibilities occurs. So it is pretty much like a drug interaction. That's an example of an interaction effect where if you mix 2 drugs together, something special happens, like, well, usually something negative, that is different from either drug taken by itself. So that's what an interaction effect is. All right, look at the results. Oh, I'm going to take this graph. Now you can right-click just to copy this if you've got Windows or Mac, which I don't. I'm not using that. And so mine's a little differently. That's why I'm doing it this way, by exporting it to an image editor, cutting it, and pasting it. Yeah. All right, anchor as character. Make it smaller. Cut it and paste it. All right, so there's my graph. You can see it looks like there's going to be a difference, that this group of people who did not revise either test seem to be scoring lower than anybody else. And the others, it's debatable whether or not there's a difference. All right, so let's move on. The assumption check is pretty complicated. So let's just say n at least 30 for all cells, or the variable is normal. I'm not even going to check it. There's no way we meet the assumption. Homogeneity of variance. Normality, linearity, homogeneity of variance, independence. But we are not. And I don't really want to check it. I just want to keep it light for purposes of this relatively introductory level class. Now, let's go do the thing. Kind of done with that. Let's go look at the output. Here's my ANOVA summary table. You'll notice that it has a separate row for 5, 7, and 5 by 7. We're going to look at all three of those p-values. Okay, I'm going to copy this table. Come back over here. Paste it. And then I'm going to change the font to be Courier New, or Courier. So there we go. And you can see there's a significant, that is the p-value is less than 0.05 for test 5, and for test 7, and for the interaction effect. So all three of those are significant. There is a main effect of revising test 5 and of revising test 7, and there is an interaction. Okay, all three. Now I've got to figure out exactly why. In a more advanced class, I would produce those results. Oh wait, I need to get my means and standard deviations and sample sizes. Never got that yet. Anyway, there are more formal tests that we can use, follow-up comparisons, but we're going to kind of skip that. Here's the sample sizes, the standard deviations, and the means for each group. So those are your descriptive statistics. Right-click, copy, paste, select it all, make it Courier, so it's legible. Okay, those are all four means, all four standard deviations, and all four sample sizes. And as you can see, none of the sample sizes are sufficiently large. We've got eight people in one of the groups. There are 8 students who revised test 7 but did not revise test 5. So that's very small. That's way less than the 30 we like. Anyway, to understand this, I'm just going to look at the graph and think about it, rather than doing more complex follow-up comparisons. As you can see, it looks like people who don't revise either are significantly lower off than anybody else. As you can also see, if I look in between here, this is on the left, people who did not revise test 7. This is sort of what the average is. Here's the average of people who do revise test 7. So revising test 7 increases your grade. The dark line, if I average these two, I get around right around here. That's the average of people who did not revise test 5. And if I average the light gray lines, that's around here. That's the average of people who did revise test 5. So revising test 5 increases your grade. Okay, revising either test alone helps your grade. Also, revising neither test significantly hurts your grade. And that's it. That's, for our purposes, that's a complete example of a results section for MultiwayANOVA. All right.